Okay, welcome to day 2 of chapter 2. Today's focus is going to look at how do we multiply and divide rational expressions. In Algebra 1, I know you did a lot of multiplying and dividing, so this isn't new. What's going to be new is maybe the level of difficulty of the factoring. We're going to throw in some AC method, maybe throw in some more difficult perfect squares problems. So the method's the same that you already used, so nothing new here. Just we're ramping up maybe the level of difficulty of the factoring. So in general, the directions might say simplify the following or multiply the following. Sometimes it says simplify, sometimes it says multiply. And you have a fraction multiplied by a fraction, okay? The process, factor, where possible, and reduce. It's the same process that we had for simplifying. Simplifying would just take one fraction at a time. And just do one fraction when we did yesterday's day 1 notes. Today we've got multiplication, same thing, you're going to factor where possible and then reduce. So let's take a look at this first problem. Okay, so factor where possible. Well, nothing factorable here. This can factor into x plus 3, x minus 3 because it's a difference of perfect squares. This factors of 15 that add to 8. 5 and 3, and a minus on each. Okay. This looks like a difference of perfect squares, but also I see a GCF here of 4 that I could take out first. So let me take out the 4 to begin with, and I have 4x, and I can take out 4x squared actually, since I'm taking out a GCF. So I'll take out 4x squared, and it gives me 4x squared minus 1. Okay, but 4x squared minus 1, that is a difference of perfect squares. So I have 4x squared, and then I'll have 2x plus 1, 2x minus 1. And that kind of what makes this different from Algebra 1 is the level of the perfect square problem gets a little bit more intricate. But other than that, the process is still the same, factor and reduce. So everything's factored, now let's reduce, okay? I look for something anywhere along the top and anything along the bottom that I can reduce with. So for example, this 4 and this 4 I can reduce, leaving me 1 in each place. I have an x squared and an x squared that I can reduce. Okay? I see an x minus 3 and an x minus 3, I could reduce that. And that's all I see from here on out. So what do I have left on top? So you're going to factor, you're going to reduce, and then whatever you have left, you just write as your answer. So it looks like I have a 1 y to the 5th, and a 1 y to the 5th I'll just write as y to the 5th. And then I multiply straight across here, x minus 5 over, I have an x plus 3 still left over. And as I come across, 4's gone, the x squared's gone, just a 1 there, but 1 times this, I'm okay. I can just write 2x plus 1, 2x minus 1. And that is what we get after we factor and then reduce. Two-step process. That's it. Sometimes more things reduce and sometimes it doesn't. You have to leave whatever you have that has not reduced. Okay? Next problem. Notice division. And you learned in Algebra 1 when we have a division. Note, change division to multiplication and flip the fraction after the division symbol. So I think some people call it keep, change, flip. All right, keep 3x plus 12 over x squared plus 5x plus 6. Change to times, flip. What's on top now becomes the bottom. So 3x squared minus 27 goes to the top. X squared minus 16 goes to the bottom. Hopefully you remember that from Algebra 1. Keep, change, flip. Now, multiplication. What are the steps? Factor, reduce. That's all we're doing is factoring and reducing. Okay? So, let's get out our factoring stick here. I have a GCF, 3, and then x plus 4. Looks like I have factors of 6 that add to 5. So that's going to be x plus 3, x plus 2. I have a perfect squares, x plus 4, x minus 4. And this has a GCF of a 3, and then an x squared minus 9. But x squared minus 9 is also a perfect square. So that leads itself into 3x plus 3, x minus 3. So that turns into that. Now, step 2, reduce. X plus 3, x plus 3. X plus 4, x plus 4. This 3 and this 3 do not reduce because they're both on the top. Anything else on top? X minus 3, do I have an x minus 3 anywhere? No. Nothing else is reducible. So what do I have left? I have a 3 times a 3, so that gives me a 9 on the top. I have an x minus 3 on the top. On the bottom, I have an x plus 2 and an x minus 4. And that's my answer. Keep, change, flip, and then factor and reduce. You have to be able to factor to solve this question. And again, this is just like Algebra 1, but some of the factoring might be a little bit more difficult is all. Okay? Let's take a look at this problem. It already is multiplication. All right? But if I notice, I don't like the order that this is written in. This is 4 minus x squared. What could I factor out of this to make this negative x squared positive? I can factor out a negative 1. So in my factoring process here, I'm going to take out a negative 1 and then write it as x squared minus 4. Because if I divide out a negative 1, the positive 4 goes to negative, and the negative x squared goes to a positive, and then I can write it. I can actually change the order of it like that. Over 2x minus 4 times 2x to the 5th, x squared plus 4x plus 4. So the first thing I did here, and it's not every problem, but I want to switch these two terms around. I want to factor out a negative 1. Okay, so now factor and reduce. Well, this is negative 1, and then x squared minus 4 is x plus 2, x minus 2. This is 2, x minus 2. Nothing factorable here. This looks like x plus 2 and x plus 2. Factors of 4 that add to 4. X plus 2, x plus 2. So factor, now reduce. All right, so what do we have? I have an x minus 2 and an x minus 2. I have an x plus 2 and an x plus 2. I have a 2 and a 2. And I think that's it. So on top, I still have a negative 1 x to the 5th. So negative 1 x to the 5th. And it's okay to have the negative 1 in there. If not, you could just write it as negative x to the 5th. That's okay. On the bottom, this is gone, x plus 2. If the only thing I had left on top was this negative 1, I have to write it. Or if everything reduces on the top to nothing, really, there's still something there. It's a 1. If the top all reduces, you still have to put a 1 in, at least. But I think we are done. So this factoring out a negative 1, if you notice, it turned these around. Started like this, turned them around, and I took out a negative 1. Sometimes what we call that is the negative 1 trick. You can make a fraction like 2 minus x into x minus 2 if you factor out a negative 1. If you factor out a negative 1. So therefore, it would turn into negative 1 x minus 2. So for example, 7 minus x, I can turn it around to x minus 7 as long as I take out the negative 1. And that's kind of what I call it. Hey, that's the negative 1 trick. Just factoring out a negative 1 takes a subtraction binomial, just two terms, turns them around. And so that way it might be able to reduce in the problem. Notice, when it was written the other way, if I factored it, it wouldn't be reducible. I turned it around with it taking out a negative 1, and now I could reduce those fractions. And that's day 2. It's all about factoring and reducing for multiplication. And if there's division, keep, change, flip. Change it to multiplication, flip it. Okay? Thanks.